When was the last time a December snowstorm created the perfect Christmas card scene across the Mid-Atlantic region? Let's begin with the ongoing snowfall that's currently creating winter wonderland conditions across the southeastern states. Emergency management agencies across the impact zone are activating winter weather protocols. Snow removal equipment is being prepared and positioned for rapid deployment. Salt and sand supplies have been checked and replenished where necessary. School districts are monitoring forecasts and preparing possible closure decisions. Many districts may announce closures Tuesday evening for Wednesday classes. Federal offices and major employers are developing contingency plans for operations. Remote work policies may be implemented during peak storm periods. And now, as promised at the 6-minute mark, here's the detailed timeline for this winter storm. Tuesday afternoon marks the beginning of light precipitation across Nebraska and Kansas. Snow intensity will remain light to moderate during the early evening hours. As of this evening, snow continues to fall throughout much of Virginia, with particularly heavy accumulations. Tuesday night into early Wednesday morning brings the transition to heavy snow. Plain states will experience their most significant accumulations during this period. Wednesday morning, the heavy snow axis shifts eastward into Iowa and southern Minnesota. Wednesday afternoon through evening represents peak intensity for the upper Midwest. Minneapolis, Madison, and Milwaukee will see their heaviest snowfall rates. Wednesday night, the storm center moves across the Great Lakes region. Chicago and Detroit enter their primary snow accumulation periods. Thursday morning brings heavy snow to Cleveland, Pittsburgh, and Buffalo. Lake effect snow may enhance totals significantly in these areas. Thursday afternoon, the storm approaches the northeast region. The Newport News and Hampton Roads areas have experienced intense snow banding throughout the afternoon. Albany, Vermont, and New Hampshire begin receiving their heaviest snowfall. Thursday evening through Friday morning covers the final phase. Boston, Portland, and Maine receive the storm's final significant snowfall. Friday afternoon, the system moves off the northeast coast and begins weakening. Snow will end from west to east across the impact region. This timeline may shift by 6 to 12 hours depending on the storm's forward speed. Faster movement would bring earlier arrival times to each region. Slower progression would delay the onset but potentially increase snow amounts. Preparation should focus on the 12-hour window surrounding these projected times. Having emergency supplies available becomes critical during extended snow events. These localized heavy snow bands have produced accumulations exceeding 6 inches in some neighborhoods. Food, water, medications, and backup power sources should be readily accessible. Vehicle preparation includes checking tire conditions and maintaining full fuel tanks. Emergency kits for vehicles should contain blankets, food, water, and communication devices. Home heating systems should be inspected to ensure reliable operation during cold periods. Alternative heating sources require proper ventilation to prevent carbon monoxide poisoning. Snow removal equipment should be tested and fuel supplies should be replenished. Ice melt and sand supplies help maintain safe walkways and driveways. Communication plans become essential when power outages may disrupt normal channels. Battery-powered radios and charged mobile devices provide access to weather updates. Now let's examine what happens after this major winter storm passes through the region. Further south, the Boone area of North Carolina has reported remarkable snowfall totals. The extended weather pattern shows both challenges and opportunities for the remainder of December. Long-range computer models indicate a temporary ridge building over the lower 48 states. This ridge pattern would push cold air masses northward into higher latitudes. However, the Northeast may remain under the influence of an Atlantic Canada trough. This trough would maintain colder than normal conditions despite the broader warming pattern. Historical analysis shows that long-range warm forecasts often trend colder as they approach. The pattern has consistently shown warm-ups in the extended range becoming cool-downs. Model trends suggest this ridge may not persist as long as initially indicated. Jet stream analysis reveals potential dips that could break the ridge pattern. These dips indicate the southern stream may become more active late next week. Higher elevation locations near Boone have received 8 to 10 inches of snow. Active southern stream energy could lead to additional storm development. December 17th through 19th represents a particularly interesting time frame. Computer models show signals for potential southern and northern stream interaction. Such interaction could produce another significant winter storm system. The Interstate 95 corridor may finally receive meaningful snowfall during this period. Cities like New York and Philadelphia have experienced below normal winter weather recently. This potential storm system could bring light to moderate snow to these metropolitan areas. However, significant uncertainty remains regarding the strength and track of any system. Extended forecasts at this range should be viewed as potential scenarios rather than definitive predictions. The overall December pattern appears to favor continued winter weather opportunities. This represents nearly a foot of accumulation in an area where December snow is typically rare. Areas that have received snow are likely to continue receiving additional accumulations. This rich-get-richer pattern has characterized the season so far. Virginia has emerged as a standout state for early-season snowfall in the eastern United States. Multiple snow events have created what many are calling a December to remember. The combination of current snowfall and upcoming storm activity supports this characterization. Economic implications of this winter weather pattern extend beyond immediate storm impacts. Multiple snow events during December affect retail operations during peak shopping season. Supply chain disruptions may impact holiday merchandise availability. Transportation delays affect shipping schedules for time-sensitive deliveries. Energy consumption increases significantly during extended cold periods. West Virginia has also overachieved expectations, with many communities reporting 6 to 8 inches. Utility companies prepare for peak demand scenarios across the affected regions. Agricultural operations require special preparations for livestock protection. Extended cold and snow exposure can threaten animal welfare without proper shelter. Feed requirements increase substantially when animals must maintain body temperature. Tourism and recreation industries see both challenges and opportunities. Ski resorts benefit significantly from natural snowfall during peak season. However, travel disruptions may limit visitor access during storm periods. Insurance companies prepare for increased claims related to winter weather damage. Roof damage from snow loads and pipe freezing represent common winter claims. Vehicle accidents typically increase during and immediately after snowfall events. Even areas as far south as Raleigh and Greensboro continue to see light snow this evening. Healthcare systems experience increased demand during extreme weather periods. Heart attacks and injuries from snow removal activities rise during major snow events. Emergency departments prepare for weather-related injuries and increased patient volumes. Mental health considerations become important during extended winter weather periods. Social isolation may increase when transportation becomes difficult or impossible. Community support systems play vital roles in checking on vulnerable populations. Don't miss our next forecast, where we'll provide updated storm track information. We'll also analyze how this storm compares to historical December snow events. Education systems across the impact zone are developing response strategies. Remote learning capabilities provide alternatives to traditional snow day closures. Northern areas of North Carolina have accumulated several tenths of an inch throughout the day. However, technology, access, and power reliability affect implementation success. Transportation authorities coordinate response efforts across state boundaries. Interstate highway maintenance requires coordination between multiple jurisdictions. Resource sharing agreements enable efficient deployment of snow removal equipment. Air traffic management systems prepare for widespread flight disruptions. Ground-stop procedures help manage airport capacity during peak storm periods. Passenger rebooking systems face increased demand as schedules are disrupted. Climate considerations place this storm within broader seasonal patterns. December snow events of this magnitude occur roughly once every 3 to 5 years. However, the timing and geographic extent make this system particularly noteworthy. Right now, snow is falling on Christmas lights throughout Virginia and North Carolina. This current system demonstrates the setup we're about to see repeated on a much larger scale. Early season storms often set the tone for remaining winter weather patterns. Active December conditions frequently continue through January and February. Jet stream configurations that produce major storms tend to persist seasonally. This suggests continued winter weather opportunities throughout the remaining season. Environmental impacts include both benefits and challenges for natural systems. Snow cover provides insulation for plant root systems during extreme cold periods. Wildlife adaptation behaviors help animals cope with sudden weather changes. Water supply systems benefit from snow accumulation that provides spring runoff. However, rapid temperature changes can stress both natural and urban systems. To summarize the key preparation priorities for this significant winter storm, now let's shift our attention to the major winter storm developing across the western United States. Plain states should complete preparations by Tuesday evening for Wednesday's heavy snow. Upper Midwest communities need to prepare for Thursday's peak storm intensity. Northeast residents should monitor forecasts closely for Friday's arrival timing. Travel plans during Wednesday through Friday should include significant flexibility. Next week, we'll provide comprehensive analysis of the Christmas holiday weather outlook. This will include potential storm systems and travel recommendations for December 20th through January 2nd. Stay informed, stay prepared, and remember that early preparation prevents weather emergencies. A powerful clipper system is currently moving through the upper Midwest. Simultaneously, significant energy is organizing over the northern Rocky Mountains. This energy is emerging from Western Canada and will become the driving force behind our next major weather event. Computer models show remarkable consistency in tracking this developing storm system. The system will gain strength as it moves from the Rockies toward the Central Plains states. By Tuesday evening, we'll see the first signs of organized precipitation across Nebraska and Kansas. However, Tuesday's activity will be relatively light compared to what follows. The main event begins Tuesday night and continues through Wednesday morning. But this beautiful scene is only the beginning of what promises to be one of the most active winter weather periods in recent memory. This represents the critical period when heavy snow develops across the Plains states. Nebraska, Kansas, and Iowa can expect 6 to 12 inches of snow accumulation. Some areas within this zone may receive totals approaching or exceeding 1 foot. Wednesday morning through Thursday afternoon marks the storm's progression into the upper Midwest. Minnesota and Wisconsin face the potential for 8 to 12 inches of snow. Illinois, Indiana, and Ohio should prepare for 4 to 8 inches of accumulation. Michigan's Upper Peninsula could receive more than 12 inches due to lake effect enhancement. Thursday evening through Friday morning brings the storm system into the Northeast region. Pennsylvania, New York, Vermont, and New Hampshire are forecast to receive 6 to 10 inches. Maine faces the potential for accumulations exceeding 12 inches as the storm intensifies. Over the next 48 hours, a significant winter storm will track from the Plains states through the Midwest to New England. The Interstate 95 corridor presents more uncertainty with projected totals of 2 to 6 inches. Metropolitan areas like New York City and Philadelphia remain on the southern edge of heavy snow. Even slight changes in the storm track could significantly affect snowfall amounts in these cities. Temperature profiles will play a crucial role in determining precipitation types. Marginally cold conditions along the southern edge may result in mixed precipitation. Elevation will become a determining factor for accumulation amounts in border regions. Higher elevations will favor snow, while lower areas may see rain mixing with snow. Let's examine the specific metropolitan areas and their projected snow accumulations. Minneapolis should prepare for 8 to 12 inches with the heaviest snow Wednesday night into Thursday. Madison and Milwaukee, Wisconsin can expect 6 to 10 inches during the same time frame. This system has the potential to deliver 8 to 12 inches of snow across multiple metropolitan areas. Chicago faces 4 to 8 inches with snow beginning Wednesday evening and continuing through Thursday. Detroit should prepare for 6 to 10 inches starting Thursday morning and lasting through the afternoon. Cleveland, Ohio will likely receive 4 to 8 inches with timing similar to Detroit. Buffalo, New York could see 8 to 12 inches or more due to lake effect snow enhancement. Albany, New York, should expect 6 to 10 inches beginning Thursday evening. Boston, Massachusetts, faces 4 to 8 inches with snow arriving Friday morning. Now here's the critical travel information I promised at 3 minutes and 20 seconds. Wednesday evening represents the most dangerous travel period for the Midwest region. Interstate 80 from Nebraska through Iowa into Illinois will experience rapidly deteriorating conditions. Interstate 35 from Minneapolis south to Kansas City faces similar challenges Wednesday night. Cities from Minneapolis to Boston are preparing for what could be their first major snowfall of the season. Interstate 94 across Wisconsin and southern Michigan will be particularly hazardous Thursday morning. Interstate 90 from Chicago to Cleveland represents a critical corridor for Thursday travel. Friday morning commuters along Interstate 95 from New York to Boston should plan for delays. State transportation departments are positioning snow removal equipment in advance. However, the rapid onset and intensity of snowfall may initially overwhelm treatment capabilities. Airlines have begun adjusting schedules for major hub airports in the projected impact zone. Minneapolis St. Paul, Chicago O'Hare, and Detroit Metropolitan are implementing winter protocols. Passengers with travel plans during the Wednesday through Friday timeframe should monitor flight status closely. Ground stops and delays become increasingly likely as snow intensity increases. Don't miss the next segment where I'll analyze the computer model data. At the 6-minute mark, I'll reveal the specific timeline showing exactly when this storm arrives in your area. This analysis reveals why meteorologists have high confidence in this forecast. Weather prediction models show remarkable agreement on this storm's development and track. The global forecast system and European models align closely on timing and intensity. Both models indicate strong northern stream energy diving southward from Canada. This energy will phase with disturbances moving across the northern Rocky Mountains. The phasing process creates the rapid intensification we expect Wednesday night. Ensemble forecast data provides additional confidence in the storm's general track. Multiple model runs consistently show the system moving northeast through the Great Lakes. Some uncertainty remains regarding the exact southern extent of heavy snow. A track shift of just 50 miles could significantly impact accumulations in border areas. The most critical travel information comes at 3 minutes and 20 seconds. The NAM high-resolution model suggests more aggressive snow amounts than other guidance. This discrepancy reflects the challenge of forecasting exact precipitation amounts. However, the overall pattern remains consistent across all major forecasting systems. Jet stream analysis reveals the atmospheric setup driving this winter storm. A strong northern stream pattern will transport Arctic air masses southward. Meanwhile, the southern stream remains less active across the lower latitude regions. This pattern favors storm development along the boundary between air masses. The potential for northern and southern stream energy to combine exists. Such phasing could enhance the storm's intensity beyond current projections. Temperature analysis shows marginally cold conditions along the storm's southern edge. I'll detail which interstate corridors face the highest risk for dangerous conditions during the Wednesday evening commute. Surface temperatures near freezing could limit accumulation in some areas. Elevation differences will create significant variation in snowfall totals. Areas above 1,000 feet elevation will favor higher accumulation amounts. Valley locations may experience rain mixing with snow during peak intensity. Wind patterns associated with this storm will create additional hazardous conditions. Sustained winds of 20 to 30 miles per hour are forecast across the impact region. These winds will combine with falling snow to create blizzard-like conditions. Visibility may drop to near zero during the heaviest snow periods. Power outages become possible when wet snow accumulates on tree branches. Utility companies are positioning crews in advance of the storm's arrival.